Hello everyone, we are going to study chemistry chapter classification of elements, and in this video we are going to study about periods and the groups in modern periodic table. So periods are the horizontal rows where properties of the elements keep changing from one to next. Okay, so these are the periods. There are 7 periods in the modern periodic table. 1, 2, 3, 4, 5, 6, 7 periods. Okay. Now these elements in these periods have different number of cells or the orbits in their atomic structure. Now we'll see elements in the period 1. Okay, these elements have only one cell or the orbit in their atomic structure, only one cell. Similarly, period 2 elements have 2 cells in their atomic structure. Period 3 elements have 3 cells or the orbits or energy levels in their atomic structure. Period 4 elements have 4 cells. Period 5 elements have 5 cells. Period 6 elements have 6 cells. Period 7 elements have 7 cells in their atomic structure. Please remember this. Now you see period 1 is called very short period because there are only 2 elements in the period 1. Period 2 and 3 are called short period. Period 4 and 5 are called long period. Okay, period 6 is called very long period. Period 7 is called incomplete very long period. It is called incomplete very long period because new elements which are being discovered are being added to this last period. New discovered elements are being added to the last period, period 7. That is why it is called incomplete very long period. Okay. Now we'll go to the groups. Groups are vertical columns where all the elements have similar properties in one group. Okay, in the same group. Right. So groups are the vertical columns where all the elements have similar properties in the same group. Right. So there are 9 groups and 9 groups are subdivided into 18 columns. You can see in the table there are 1 to 18 vertical columns in this table. Okay. Now you see elements in group 1. Elements in group 1 have 1 electron in their valence cell. Only 1 electron in their valence cell. 1 electron in their valence cell. All these elements, and all these elements have similar properties in them. Similarly, elements in group 2. This is group 2A. Right. This is group 2A. These elements have 2 electrons in their valence cell. Supposing this is valence cell, there are 2 electrons in their last cell. Valence cell means last cell. Group 3A. Now we'll talk about subgroup A. Okay. Now because actually we study subgroup A elements in this periodic table. So elements in group 3 have 3 electrons in their valence cell. Valence cell means last cell. Likewise, group 4A elements have 4 electrons in the valence cell. Yes, 5A elements have 5 electrons. 6A elements have 6 electrons. 7A elements have 7 electrons in the valence cell. And group 8 elements. Okay, group 8 is over here. We'll talk about later. Now you'll see group 0 elements. Column 18 is 0 group elements. Hey, these 0 group elements have 8 electrons in their valence. 0 group elements have 8 electrons in their valence cell. Supposing this is the valence cell of 0 group elements, this one 18. Okay, inert gases. So they have 8 electrons in their valence cell. 1, 2, 3, 4, 5, 6, 7, 8 electrons in the valence cell. So you have to remember this one. Group 1A elements have 1 electron valence cell in the valence cell. 2A elements have 2 electrons in the valence cell of their atomic structure. 3A elements have 3 electrons in the valence cell of their atomic structure, and so on. So these are the groups in the modern periodic table. Now these are group 8 elements. Group 8 elements. Group 8 elements elements have valence electron ranging from 1, 2, 3, 4. Okay, we'll study about them later, right? Because these are the elements with special properties. Okay, now in the periodic table study, we mainly talk about subgroup A elements. Actually, we study about subgroup A elements, right? So besides this classification table, modern periodic table has 4 blocks in it. Okay, 4 blocks in it. These are called SPDF blocks. These blocks are actually based on subcells or the orbitals. We'll study about them later, subcells. Now you need to understand there are 4 blocks in this modern periodic table. Those blocks are S block. S block elements are group 1A and 2A. Group 1A, 2A are S block elements. These are S block elements. 1A and 2A. S block elements. Yes. Group 13 to 18 P block elements. These are P block elements on the right side of the table. Non-metals, right? Non-metals are P block elements here. And SPDF. Okay, D block elements are, okay, these are D block elements from number 3 to number 12. Entire middle part is D block element, and F block elements are here lanthanides and actinides. This separate part of the periodic table, this is F block. Okay, elements, F block elements are here at the bottom of the table separately. Okay, so S block, SPDF blocks, S block elements, P block elements, D block, DF blocks. So you need to understand this also. Now we'll see the position of elements in the periodic table. Okay, group 1A elements, you see group 1A, the first column. 1A elements are called alkali metals because alkali means base. Alkali means base. Okay, so alkali metals because these metals dissolve in water readily, quickly to form hydroxides, very strong hydroxides. For example, sodium Na. Sodium forms sodium hydroxide after dissolving in water. Okay, they are very soluble in water and they form very strong alkalis, very strong alkalis. So example, sodium hydroxide, potassium hydroxide. Okay, so sodium dissolves in water readily, quickly to form sodium hydroxide. Potassium dissolves in water quickly to form potassium hydroxides. That is why these are called alkali metals, because they form bases or alkalis. Okay, yes, bases which are dissolved in water are called alkalis. No, alkalis and bases are actually, these are same. So sodium hydroxide, potassium hydroxide are called alkalis or the hydroxides. Okay, so that is why group 1A elements are called alkali metals. Alkali metals. Okay, and group 2A elements are called alkaline earth metal. Alkaline earth metal. Alkaline earth metal means these elements also form hydroxides, to form hydroxides just like group 1A elements, but their hydroxides are not as strong as group 1A elements. Okay, yes, so alkaline earth metals are called 2A elements are alkaline earth. These elements, magnesium, calcium, these also dissolve in water to form magnesium hydroxide and calcium hydroxide. Magnesium hydroxide and calcium hydroxide. Hydroxides are not as strong as this. Sodium hydroxide, potassium. Yes, these are still strong. Okay. Okay, so alkali metals, alkaline earth metals. Alkali metals are group 1A elements. Alkaline earth metals are 2A, group 2A elements. Now we'll see group 6A. Group 6A elements are called chalcogens. Okay, oxygen, sulfur, etc. Okay, chalcogens because they are found combined with copper in nature. Chalcogens, group 6A elements. These are non-metals. And group 7A elements, fluorine, chlorine, bromine, iodine. This group, 7 group is important. So 7A elements have, these are called halogens. Group 7A elements are called halogens, 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 because these elements combine with these elements, these non-metals combine with group 1A elements to form salt. For example, chlorine. Can you see this chlorine over here? And can you see the sodium? So chlorine combines with sodium to form sodium chloride, NaCl. Right? So halogens, group 7A are called halogens. 7A elements are called halogens. Halogens combine with group 1A elements or alkali metals to form salt. Salt, salt, NaCl is salt. So these are called halogens, group 7A elements. That is why they are called halogens. Group 7A elements combined with group 1A elements or the alkali metals to form salt. Example, sodium chloride. That is why these are called halogens. Okay. Now we'll see group 0 elements or group 8 elements. Right? Group 8 elements have electrons in their valence shell. Okay, because of 8 electrons in their valence shell, these elements do not take part in chemical reaction. That is why these are called inert, means not reactive. Inert means not reactive. Since they already have 8 electrons in their valence shell, they neither gain electron nor lose electron in the chemical reaction. That is why these are called inert elements or inert gases. Group 0 elements. Group 0 elements: helium, neon, argon, krypton, xenon, radon. Okay, so these elements are group 0 elements or inert gases or noble gases. Right, group 0 elements. Now we'll see next group is these are hydrogen, position of hydrogen. We know the position of hydrogen. Hydrogen can be kept in group 1A as well as in 7A. It is because it can be kept in 1A because it loses one electron, just like lithium, sodium, potassium, to take part in chemical reaction. Okay, loses one electron and become H plus. Yes, at the same time it can gain one electron, just like chlorine, fluorine, and become H minus, right, to take part in chemical reaction. So this is electronegative, H plus electropositive, right? So this way hydrogen can be kept in group 1A as well as in 7A, but it is kept in the beginning of the table due to its least atomic number, that is atomic number 1. That is why it should be in the beginning. So position of hydrogen. Now we'll see the position of transition elements, group block D elements. This one, these are subgroup B also. Okay, these elements are. So group or the block D elements are called transition elements. Transition elements, transition transition elements, because they transit to A to 3A. Okay, this middle part is in between 2A and 3A. That is why these are called transition elements. They transit through group 2A to 3A, right? So group D elements are block D elements have their electrons being filled in D subcell, right? We'll study about this later. Electrons are being filled in D subcell. That is why these are called block D elements, and these are called transition elements. And similarly, F block elements. F block elements are lanthanides and actinides. Okay, there are 14 elements in each row over here, and all these 14 in the upper row have similar properties, and all these 14 elements in the lower row have similar properties in them, right? So these are called, upper one are called lanthanides, lower are called actinides. These are called F block elements because electrons are being filled in F subcell in their atomic structure, F subcell. That is why these are called F block elements. Okay, so these are positions of different kinds of elements in the periodic table. With this, we finish this discussion. In the next part, we are going to see the properties of periods and the groups.